ways of presenting my sharing. Okay, can you see my screen? Can you hear my voice? Semua boleh nampak?
Boleh, Doktor.
Okay, thank you for the response. Okay, so last week we have stopped until this topic, which is power calculation in angle modulated signal. So this is for the total power calculation for the angle modulation signal, which is for frequency modulation and also for the phase modulation. Okay, so last week we have seen these equations. Power equal to 1/2 VC square multiplied with summation of Jn square from minus infinity to infinity. Okay, and again, power calculation should have R component, resistance. So you might wonder, where does the R component, where does the R variable in this equation? Okay, so actually there's a R equations over here, which is supposed to be divided with R. Okay, sepatutnya ada R. Again, the equation for power is still the same daripada dulu, kini dan selama-lamanya. So if you remember, VRMS square over R, or you can say that this is a V peak square over 2R. Okay, so whatever it is. So I believe this is using the peak value. So it is supposed to be this 2 should be here. So it will be it's supposed to be like this. So VC square summation of Jn square from minus infinity to infinity. Divide with 2R. So dia ada bahagi dengan R. Okay, so kalau saya kembangkan dia boleh jadi seperti inilah. So you see that the R variable is still there, but in this case they assume that the resistance is equal to unity, which is R equal to 1. So dalam case ini dia menganggap R bersamaan dengan 1. Okay, and if you see from here, the last over here, you see that this is a VC square over 2R. Actually, we have R equal to 1 in this example. Okay, so this is equal to power of the carrier. Okay, so you might wonder, where does the Jn square parameters? Apa yang berlaku kepada Jn square? So according to Bessel's theory, okay, one of the Bessel's properties said that summation of Jn square from minus infinity to infinity would be equal to 1. Okay, so this is one of the Bessel's properties, say that this is the summation of Jn square from minus infinity to infinity would be equal to 1. So ini adalah property, one of the Bessel's property. Okay, so at the end you see that this the total power, so this is actually total power is equal to the carrier power. So you might wonder, where does the total power comes from? So this is the total power in this topic, in this example. It is actually the power supplied to the antenna. Okay, dia sebenarnya adalah kalau kita lihat di pihak di bahagian transmitter. So when we measure the total power, it is actually the power that supplied to the antenna. Okay, whereas the resistance here is the antenna resistance. Okay, and this antenna will radiate the signal in the form of electromagnetic wave. Okay, so total power ini adalah power yang kita supply kepada antena. Okay, dan dia antena kemudiannya akan radiates ataupun memancarkan signal ini dalam bentuk gelombang elektromagnet ke dalam channel ataupun medium. Okay, so after we supplied the total the power, the signal to the antenna, so what happened next? What happened next? How does the antenna radiates the signal? What happened to the signal in the channel? So that one you will learn in chapter 5, the last chapter. Okay, dalam chapter 5 ada diterangkan macam mana antena ini berfungsi. Okay, apabila diterima signal, okay, dia terima signal dengan sejumlah certain power supplied to it, and it will radiate that signal in the form of electromagnetic wave to the free space. Okay, and then how does the wave properties when it travels from transmitter to the receiver? That one also we will learn in chapter 5. Okay, so you see that here from these equations, the total power is equal to the carrier power, like this. Okay, P total would be equal to the carrier power. Okay, and you see that what is the carrier power? Carrier power as usual, PC. So this is supposed to be subscript of C. So PC macam ni C dia besar sangat, patutnya PC kecil je lah. So C is supposed to be subscript. So this is again, this is also subscript. So this is a VC square over 2R, power in watt. Okay, so again, when we calculate the total power, we can also calculate based on the summation of all frequency component powers. Okay, macam yang kita buat dalam AM sebelum ini, yang mana kita tambahkan semua power daripada setiap frequency component. Okay, so the method is still the same actually. Methodnya juga masih sama sebenarnya. So kalau you lihat dalam FM ataupun angle modulated wave, we gonna have many sidebands. Kita akan ada banyak sidebands. Dia berbeza dengan AM. AM paling hebat pun dia ada up to 2 sidebands. Up to a pair of sidebands. Double sideband full carrier. Berbeza dengan angle modulated wave, yang mana dia akan ada banyak frequency components. Okay, so for example here, okay, katalah di sini so you see that we're gonna have for example, this is a carrier, okay, carrier, and we have a lot of sidebands. So the way we calculate the total power is we do the summation of all frequency component. For example, this is P0, P1, P2, P3, P4. For example, this is P1, P2, P3, P4. So we need to add all the power components, then we get the total power. Okay, so inilah dia equationnya. So total power also can be calculated by, we do the summation of all powers of the carrier of the frequency component. So this is P0 from the carrier component plus 2 times P1 plus P2 plus P3 plus until Pn. So it depends on how many sidebands are there. Okay, why does we need to multiply with 2? Because we have upper and lower sidebands. Ada dua bahagian so dia sepasang. So kita calculate semua sekali lah. Okay, so if you see from here, what is P1, what is P2, P3, and so on. So remember that the P is actually Pn. So the equation for Pn is equal to Vn square over 2R. So what is Vn? So Vn is the real amplitude. Okay, Vn is the real amplitude, and you have learned about Jn. Jn is the relative amplitude. Jn is Vn over Vc. So this is where you get the relative amplitude from the Bessel table. Okay, and Vn is equal to Jn multiplied with VC. So ini pun ada diterangkan di sini. Okay. So this is the real amplitude of the spectrum. Okay, the amplitude of the spectrum. Jn is the relative amplitude of the spectrum. Vn is the real amplitude or amplitude of the spectrum. So dia ada satu relative amplitude, satu lagi amplitude. Itu amplitude sebenar. Okay. So Vn is like this. So okay. So if you see from here, this is actually Jn square Vc square over 2R. Okay. Yang mana di sini kalau you lihat sebenarnya dia ada komponen PC. Vc square over 2R is actually equal to PC. So it is actually, you can say that this is actually Jn square PC. Okay. So, itu sebabnya di sini dia buat seperti itu. So if you see from these equations, so it is V0 square over 2R plus 2 times V1 square over 2R plus V2 square over 2R, V3 square 2R until Vn square over 2R, where this V0, again like V0, this is J0 Vc square, this is J1 Vc square, V2 here is J2 Vc square, this is J3 Vc square until Jn Vc square. Okay, so this has a carrier power component. Okay, so kalau you lihat sebenarnya ini macam yang saya buat tadi lah di sini. So di sini ada a carrier component power. Okay, Vc square over 2R. Okay, Vc square over 2R, adanya Vc square over 2R. So Vc square over 2R is PC. Okay, so that's why they rearrange the equations. It becomes J0 square PC plus 2 times J1 square PC, J2 square PC, J3 square PC until Jn square PC. So where does the PC comes from? PC comes from Vc square over 2R. Okay. So if you see from this equation at the end, theoretically you will get equal to PC. Secara teorinya kamu akan dapat bersamaan dengan PC. Okay. And if you see from this statement, okay, kalau dilihat dari statement ini, the total power in the carrier and the sidebands components is approximately equal to unmodulated carrier power. So dalam statement ini, dia katakan seperti ini P total is approximately equal. Okay. Is approximately equal to PC. Kalau you lihat di sini, statement ini agak bercanggah sedikit berbanding dengan statement yang kita telah belajar tadi, iaitu total power bersamaan dengan PC. Okay, so remember that theoretically PT is equal to PC. Total power equal to carrier power. Theoretically correct. Okay, but what about this statement? So this statement wants to relate with the Bessel table in your notes. Okay, kenapa dikatakan approximately equal? Later you're going to see in the example, semasa you mengira total power menggunakan Bessel table, you will find out that the total power is slightly different from the carrier power. So the word slightly different here means that it is only difference in terms of a few decimal point only. Contoh, you kira dapat menggunakan Bessel table, okay, sebab kita guna Bessel table untuk to find the value of J. So when you use the total power, you use the Bessel table, use the long equations, when you calculate the total power, suddenly you find out that, okay, the value is about 10.005 watt, for example. And when you calculate the carrier power, you find out that the carrier power is 10 watt. So the difference might be around 0.05 watt, for example. So that is the difference. If you use the Bessel table in your notes, compare if you use the equations for the carrier. Kenapa macam tu? Why is it like that? So we need to go back to the Bessel table. Okay, kita perlu kembali kepada Bessel table yang ini. And if you see from here, this table, okay, has neglect all the values less than 0.01. So semua nilai yang kurang daripada 0.01 telah diabaikan. Diabaikan dalam kes ini dia jadikan dash. So there might be a sideband which is very, very, very small, but it is insignificant. Itu pun telah dinyatakan dalam sini. It is already been stated here that the sideband, sekejap bawa ni, bawa homework PDPR, bawa di sekolah. PDPR semua, cikgu suruh bawa PDPR di sekolah, homework dah siap. Dah siap lah. Yang berkaitan hari ni, hotel pemahaman. Bawa homework PDPR di sekolah. Okay, so in the slides, it's already been stated that the Bessel table in the notes have neglect the value, the sideband which has a magnitude of 0.01 and below than 0.01. So consequence from these issues, you're going to get a power that's slightly less from the theoretical value, which is okay, no problem, tidak ada masalah. Okay, so you might wonder if in the exam, okay, kalau dalam exam, which one should I use? The long equation or the short equation? So kalau you tanya saya, okay, which one should I use in the exam? Should I use the long equations or can I use like this, PT equal to PC? Okay. So the answer is yes, you can. Okay, dalam exam, kalau diminta untuk mengira total power, find the total power for the FM, for example, you can make it as equal to PC. No problem. Okay, so if the question asks like that in general, find the total power, then you can use these equations. Unless melainkan soalan secara spesifik wants you to calculate the total power using the Bessel table given in the paper, for example. Contoh, kalau diminta mencari power menggunakan Bessel table, bermakna dia minta you gunakan persamaan yang panjang. Okay, persamaan yang long equation ini mempunyai nilai J. So kenapa macam tu? Mungkin soalan ingin kamu terbiasa dengan Bessel table, for example. Okay, tetapi biasanya dalam exam apabila kami tanya find the total power, so it is straightforward. You can use the short equation. Okay, tidak ada masalah. Nanti akan ada example selepas ini untuk menunjukkan perbezaan tentang dua equation ini. Nanti you akan lihat bahawa perbezaannya sangat kecil. We can assume it is equal to PC, no problem. Okay, so jelas. So let's go to the example. Let's look in the example. The first example here, example 3.7. Okay, example 3.7 in an FM signal is given as VFMT 12 cos 6 pi multiplied with 10 power of 6t. Plus 5 sine 2 pi times 1250t. So you should understand the general equation for FM. kamu perlu faham macam manakah struktur persamaan angle modulation. Itu seperti ditunjukkan dalam slide-slide sebelum ini ya. Okey, yang mana dia adalah bersamaan dengan VC cos 2 pi f ct plus beta f sin 2 pi 1250t. So kamu perlu faham macam manakah bentuk struktur kamu perlu faham struktur persamaan angle modulation. Sebab kalau kamu faham strukturnya, okey, bukan hafal equation, maksudnya kamu faham struktur equation itu, dengan cara melihat equation ini kamu dah boleh faham apakah itu VC, apakah itu frekuensi. So daripada sini saya dah boleh nampak. Okay, if you ask me, if you're given this kind of question, straight away you convert to the main parameters. For example, from this equation, I can extract straight away. I can extract the value of VC. This is VC actually. Okay, and what about this is we can get a carrier frequency from here. So if I from here I need to divide with 2 pi, 6 pi times 10 power of 6 divide with 2 pi. Okay, because this is a 2 pi FCT. Ini sebenarnya adalah 2 pi FCT. So if I want to get this one, so therefore this is actually equal to 3. 3 times 10 power of 6. So this is actually FC. So FC is 3 megahertz. Okay, plus 5. What is 5? 5 here referring to the beta F. Why beta F? Because this is FM. If this is PM, kalau ini adalah PM, bermakna dia merujuk kepada beta P. Okay. Itu sebab you need to understand the structure of the equation. Okay, you need to understand the structure of the equation. Okay, so from here I can determine the value of a modulating frequency, which is so I divide with 2 pi. So therefore FM modulating frequency is equal to 1250 hertz. Okay, this is also hertz. Daripada soalan saya dah boleh tahu banyak perkara. Okay, so from equation straight away convert to the important parameters. Then you can answer the question. Okay, so determine first question frequency of the carrier signal. Okay, we already determined the carrier frequency from this value. So you need to divide with 2 pi. So I already done this. So this is actually equal to 3 mega. 3 times 10 power of 6, or you can say that this is 3 megahertz. Okay, simple, very straightforward. Determine the frequency of the modulating signal. Again, this is already been determined here, which is equal to 1250 hertz. Okay, so this is in terms of hertz. And then what? Modulation index. Very easy. Beta F sama dengan 5. This is from the equation. Okay, so ini senang sangat. So dalam exam tak macam ni lah. Okay, sebab terlalu senang. This is straightforward, for example. Okay, so determine next D. Determine frequency deviation. Frequency deviation is delta F. Remember delta F? Delta F is equal to KF VM. Okay, delta F is equal to KF VM. Or you can also derive delta F from beta equation, modulation index equation. If you remember, this is beta F is actually equal to delta F over FM. So therefore, you can write delta F is equal to beta F modulation index multiplied with modulating signal frequency. Okay, so you get here 5 multiplied with 1250. Okay, so ni boleh sama-sama kira 6250 6250 6250 hertz. Okay, 6250 hertz. So you can also use your calculator. Okay, boleh guna calculator kamu untuk sama-sama kira. We can calculate together. Okay. Okay, the last one is power dissipated in 10 ohm resistor. So sebenarnya apa yang berlaku adalah dalam real scenario, the resistance is actually referring to the antenna resistance. Sebenarnya resistance yang dimaksudkan di sini adalah antenna resistance. Okay, so this is a transmitter. Okay, so remember that we supplied, we supplied a VFMT to the antenna, and this antenna has a R equal to 10 ohm. Ini yang sebenarnya dia macam tu. Dia bukan resistor macam ni, bukan resistor ni. Sebenarnya dia merujuk kepada antenna resistance. Okay. So from there, then you can, that means you supply the total power to the antenna. Okay. So therefore we can calculate the total power. Okay. So total dalam kes ini saya boleh guna persamaan ringkas. P total equal to PC, which is equal to VC square divide with 2R. So this is VC, how much? VC is 12, so that means 12 square divide with 2. Okay, so you will get this equal to 7.2 watt. Straightforward. Okay. Ada soalan boleh tanya. Okay, ada soalan boleh tanya. No problem. So, if you have question, ask now. Otherwise, I move to the next example. Example 3.8. Okay, kalau tak ada soalan, saya teruskan. Okay, example 3.8. Determine the unmodulated carrier power for the FM modulator given that beta equal to 1. VC equal to 10 volt or 50 ohm, then determine the total power in the angle modulated wave. Nampak So soalan sebenarnya tanya dua perkara. Satu, dia tanya determine the unmodulated carrier power which is equal to PC. Then the second question asks you to find the total power PT. Secara teorinya PC and PT is equal. Theoretically. So apa sebenarnya yang soalan ni nak? Okay, apa yang soalan ni nak sebenarnya? Okay. So this question actually wants you to compare carrier power, unmodulated carrier power with the total power. Maknanya apa? Dia nak suruh you compare antara PC dengan total power sebenar menggunakan long equations. Okay. So no problem. Let's do it. So dia nak tunjuk. So this example wants to show you the difference, the slightly different between PC and PT total. Okay. So let's do it. So here PC. So PC equal to VC square over 2R. Okay. So di sini which is 10 square divide with 2 times 2 times 50, 2 times 50, so this is equal to 1 watt. Okay, 1 watt. And then what? So we want to calculate the total power PT using the long equations. So if you want to use the long equation, that means we need to refer to the Bessel table. Okay, if you want to refer to the Bessel table, first of all, we need to know how much is the value of beta. Kalau tak tahu nilai beta, kita tak boleh nak rujuk Bessel table. We need to know how much is beta. So beta is given as 1. So if you refer from the Bessel table, okay, kalau refer kepada Bessel table, Okay, if beta equal to 1, that means we're gonna have up to 3 significant sideband. Akan ada 3 significant sideband, yang mana value of J 0.77, 0.44, 0.11 and 0.02. Okay, so go back to the slide. Okay, so that means we're gonna have a J0. Okay, J0 is equal to 0.77, J1 is equal to 0.44, J2 equal to 0.11. So ini daripada Bessel table for beta equal to 1. Okay, and J3 is equal to 0.02. Okay, so from here you can calculate the total power. Remember the total power P total using the long equations. So we can find this is J0 square PC plus 2 times. Okay, so this is up to 3 significant sidebands. That means sehingga, okay, kalau saya buat persamaan penuh lah senang supaya kamu faham sikit Okay. So it's supposed to be like this, P0 plus 2 times P1 plus P2 plus P3. Okay, because up to 3 significant sideband. So therefore, this is supposed to be J0 square PC plus 2 times bracket here is so this is a J1 square PC plus J2 square PC plus J3 square PC. Okay, so ini tinggal terus masukkan nilainya, which is this is 0.77 square in bracket 1 plus 2 times here is 0.44 square, this is 1 plus 0.11 square plus 0.02 square. Okay, so ini boleh kira lah. Okay, 0.00 square, you will get 5929. So this is 0.5929 plus so 0.44 square plus 0.11 square plus 0.02 square multiplied with 2, so 0.4122. So at the end you will get plus 0.5929. So you get 1.0051 watt. Nampak tak beza dia? So you see that from PC we get 1 watt. When we calculate using the long equation, we get 1.0051 watt, which is approximately, we can say that this is 1 watt. Okay, so example ini sebenarnya ingin menunjukkan kepada kamu apakah perbezaan PC and PT if you are using the table in the notes. Nampak so that's why statement ini keluar not exactly equal because values in Bessel table has been rounded off. So kenapa ada perbezaan sedikit ini? Kerana Bessel table dalam nota telah dibundarkan. So walaupun dibundarkan, dia tidak menjadi masalah kerana perbezaan itu sangat kecil. Okay, so class, if you get the value 1 watt and 2 watt, that one is bigger, very big. So biasanya perbezaan dia cuma beberapa titik perpuluhan sahaja. Okay. So again, as I told you in the exam, of course you can write P total equal to PC. No problem, tak ada masalah. Okay. So do you have questions about this example? If you don't have question, then let's look the next example.
Doctor.
Yeah, yeah, silakan.
Just can you explain again how to get the J? Just now I missed it.
Oh, how to get the value of J? Okay,
J0, J1.
okay, sure. Okay, so value of J, the way I get the value of J is from the Bessel table. So when we want to get the value of J, first of all, you need to know how much is the value of beta. So the value of beta F is the modulation index. Okay, modulation index is given in the question, which is equal to 1. Okay, so apabila kita ingin melihat Bessel table, we need to know the beta parameter. First of all, we need to know the beta parameter. Kalau tak tahu beta parameter, we cannot refer to the Bessel table. Okay, kita perlu tahu berapakah nilai beta. So that's the first thing. So beta is given in the questions. So that means I can go back to the table. Saya pergi kepada table. So thank you for asking the question because you need to know how to use the table. Okay. So if you see from this table, you see that here modulation index beta F, and all here is the sideband component. Okay, sorry, this is okay. So over here is the carrier component, and the rest is the sidebands component. Okay, so given beta is equal to 1 in the question. So that means I need to find where is beta equal to 1. Okay. So saya padam je lah. So from this table, beta equal to 1 is this one, this row, baris yang ini. Okay. So this row shows that I'm gonna have there are 4 components. Okay. That means here is the carrier component. So kalau saya lukis, okay, kalau saya lukis seperti ini. So saya padam je. So I'm gonna have a carrier component and I have a 3 pairs of sideband. Saya akan ada 3 pasang sideband. Yang pertama saya akan ada carrier component. Okay, this is FC. Okay, which is at J0. And then I'm gonna have a J1. This is also J1. Okay, J1. Okay, this is FC plus FM. This is FC minus FM. Okay, and then I'm gonna have another one here, J2. This is, okay, here over here is also J2. This pasang this pasang. So that means here is FC plus 2FM. Okay, FC plus FC minus 2FM. And then what? Then I have another, the third one, located at FC plus 3FM. Over here also located at FC minus 3FM. Okay, and the relative amplitude is J3. Nampak So daripada sini, the number of significant sideband, if you remember that we have learned about n parameter, number of significant sideband is equal to 3. So that means we have 3 significant sidebands. That means we have 3 pairs of sideband. So dari sini kita ambil value-nya. J0 0.77, J1 0.44, J2 0.11, J3 0.02. Inilah value yang saya ambil. Okay, and from here I take the value and I put in the calculations. I go back to the slide. Itulah sebabnya saya dapat value ini daripada table. Okay, then I can calculate the total power. Boleh
Boleh, Doktor.
Okay. Any other questions? Ada soalan lagi nak tanya? So, okay, kalau ada boleh tanya, kalau tak ada saya akan teruskan. So I move to the next example 3.9. Okay. So this is a good example. Okay, ini adalah example yang bagus as a practice for the final exam. Because if you see from the in the final exam, the question is structured A, B, C, and so on, where you see that the question is in sequence actually. First find this parameter, next find another parameter, next find another parameter, like that. Okay, biasanya soalan itu bersistematik, one by one. Okay, and biasanya kalau kalau kita dah cari parameter yang sebelumnya, kita boleh gunakan parameter tersebut untuk soalan berikutnya. So the risk, bahayanya adalah kalau kita salah soalan di bahagian yang awal, ada kemungkinan kita salah soalan untuk bahagian seterusnya. Okay, because the question is related to each other. Okay, kita ada satu soalan besar dan dia ada dia punya sub questions. Okay, so this kind of example is, in my opinion, is a good example for practice. Okay, kalau you nampak dia ada banyak Okay, so let's look here, example 3.9. Okay, example 3.9. Given an FM signal, so kita tahu bahawa ini adalah frequency modulation. Okay, and you are given the parameters of VFMP. Okay, so perhatikan kelas, ini just a good practice, only a good practice. You see that the way they do the way they write the parameter VFM, it is a small v. Small v is for equation. Kalau capital V, this is for constant parameter. Itu cara menulis lah mathematics. Okay, so kalau you dah terbiasa, biasanya huruf kecil adalah untuk equations. Okay, untuk persamaan. Function, it's a function. For capital letter is for the constant parameter. Itu biasalah. Okay, and it is equal to 1000 cos 2 pi times 10 power of 7t plus 0.5 sin 2 pi 10 power of 4t. Again, you need to understand the structure of FM equation. Okay, because for me, I understand this, so straight away I can determine how much DC, how much FC, how much beta, how much FM, modulating signal. Okay, straightforward. So this is, you see that from here, this is DC. What about here? I can determine a carrier frequency from here. So that means this is FC. FC is equal to 2 pi times 10 power of 7 divided with 2 pi. So this is equal to 1 times 10 power of 7. Or you can write this is 10 megahertz. And then what? 0.5. 0.5, this is actually the beta parameter. Saya tahu sebab ini adalah struktur persamaannya merujuk kepada beta. Macam mana saya tahu? Mungkin you tertanya-tanya, okay, tak apa. So macam mana saya tahu? Saya kena kembali kepada soalan persamaan asal. So I just want to go back, flashback. Okay, flashback. Okay. Ini nak tunjuk. Thank you. Ni. Okay. So, ni tak ada tulis beta pula. Sekejap. Tak ada tulis beta. Oh, tak ada pula. Tak apalah. Yang ni pun boleh juga. Okay. So you see that here, this is beta, this is VC, this is beta. Okay, this is beta. So beta you see from here. So the structure is VC sine or VC cos, tak ada masalah, sine or cos, no problem. Big bracket, this is 2 pi FCT, 2 pi FCT plus beta cos omega MT. Omega MT is 2 pi FMT. So this is the structure. Okay, so saya boleh buatlah seterusnya. So I go back to the slide. Okay, so I go back to the slide. So here, this is beta F. So from here, I can determine how much is Fm. So Fm is equal to 2 pi times 10 power of 4 divided with 2 pi. So this is actually 1 times 10 power of 4. Ataupun you boleh, this is hertz, hertz. Ataupun, ni pun sama tadi hertz. Ataupun you boleh tulis sebagai 10 kilohertz. 10 kuasa 4 adalah 10 kilo. 10 kilo. So what? And then R is given as antenna. You see that antenna resistance is given as 50 ohm. R. Telah ada dalam soalan. And then what? Determine the unmodulated carrier power. Carrier power yang asal lah, carrier sebelum dia, kenapa dia katakan unmodulated? Sebabnya carrier pada awalnya adalah carrier and then dia modulate dengan information signal. So that carrier, the original carrier, so how much is it? So this is actually PC lah. So ini adalah PC is equal to VC square over 2R, which is equal to 1000 square bahagikan dengan 2 times 50. Oh, ini besar, which is 10 kilowatt. Okay, 10 kilowatt. Okay, so so now please you can cross check my answer with calculator. So sama-sama kira. So semalam section 1 saya ada buat kesilapan mengira. So pelajar betulkan. So kalau you tak betulkan nanti sampai hujung semester salah. Okay. So sila bantu saya untuk mengira. So okay, from here modulation index beta F. So how much is beta? Beta F is of course dah diberi dalam soalan. Beta F is equal to 0.5 from the question. And then what? Find third questions, find the peak frequency deviation, which is delta F. How much is delta F? So since we know beta, we already know modulating signal frequency FM, then we can calculate delta F, frequency deviation, which is equal to beta F multiplied with FM. Okay. Persamaan delta F ada dalam slide sebelumnya. You boleh rujuk. So this is equal to 0.5 multiplied with 10 kilohertz. So you're gonna get 5 kilohertz. Okay. And then what? Then the question asks, calculate the modulate. Okay, so determine the modulation sensitivity. Question number 4. Modulation sensitivity if. So the question asks modulation sensitivity. Apa benda ni? So ini merujuk kepada parameter K. So in this case, it is actually referring to KF. Okay, KF. Modulation sensitivity parameter. Okay, if you are given a voltage which is 200 millivolt required to achieve part C. Maknanya apa? Maknanya dikatakan di sini berapakah nilai KF supaya kita boleh mencapai nilai delta F dalam C. So ini sepatutnya number 3 question number 3 so how much is KF in order to achieve delta F equal to 5K given this. Okay, given this. So if you see from question 3, delta F So delta F, if you remember, delta F is actually equal to Kf Vm. Okay, Kf Vm. So you want to find Kf, you already been given Vm. Vm is given here. Macam mana saya tahu ini adalah Vm? Okay, because we already know Vc. Okay, we already know Vc, and the question in C or in question 3, frequency deviation is not related to Vc. So this is actually related to Vm because delta F is proportional to Vm. Dalam kes ini, parameter Vm tidak diberikan sebelumnya. Now dia berikan parameter Vm because in frequency deviation berkadar langsung dengan Vm. Okay, so when you want to find Kf, so Kf is equal to delta F over Vm. Okay, so that means 5 kilohertz divide with 200 millivolt. So ini berapa? Cuba kira ya, 5K dibagikan dengan 200 milli. So you get 25,000. Okay, so 25,000 ataupun saya boleh letak 25K lah. Unitnya apa? Unitnya adalah hertz per volt. Okay, hertz per volt. So this is the modulation sensitivity parameter. Okay, unitnya dalam hertz per volt. Sebelum ini pun you telah belajar bahawa Kf sebenarnya boleh juga dalam unit radian per second per volt. Itu kalau you darabkan dengan 2 pi. Okay, if you multiply both above and below with 2 pi, so therefore you get ini radian per second per volt. Ini ada dinyatakan dalam slide sebelumnya. Saya flashback. Ini So beta F can be radians per second per volt. Kf can be in term of radian per second per volt, ataupun Kf boleh juga dalam sebutan hertz per volt. Okay, so dalam konteks ini saya menggunakan hertz per volt, yang mana Kf Vm adalah bersamaan dengan delta F. So beta F sebenarnya adalah delta F over Fm. Okay, where delta F is equal to Kf Vm. Okay, so I go back to the slide. Okay, so dapat 25 kilohertz per volt, and then what? Amplitude spectrum. Amplitude spectrum. So kelas kali ini kita nak buat kerja, hari ini kita punya pengiraan agak penat sikit okay? Kerana ada beberapa perkara yang kita kena kira, nanti you akan lihat So the next question, question 5 Question 5 say that you need to find an amplitude spectrum. Maknanya apa? Maknanya kamu kena lukis sebenarnya dia minta untuk melukis find the amplitude spectrum. So dalam kes ini sebenarnya dia minta kamu lukis spektrum. Okay, find the amplitude spectrum. So dalam kes ini you kena lukis amplitude versus frequency. Okay, amplitude spectrum. Okay, so in order to do that, you need to find the amplitude of each spectrum, then you can draw. Okay, so macam mana nak cari? Untuk mencarinya kita perlu buat table. Okay, kita perlu buat table. So ini yang penat sikit ni. So semalam pun kira-kira penat juga So I will share whiteboard. So I can share whiteboard. So we need to open a whiteboard. Which one? Whiteboard. So whiteboard, start a new whiteboard. So send to all of you. Okay. So let's do question number 5, which is find the amplitude spectrum. So amplitude spectrum, if you see from here, so I rewrite again the equation. So I rewrite again the parameters. You are given, you are given the beta parameter. Beta f is 0.5. You are given BC. You are given BC is given as 1000 volt. FC is given, so FC is given as 10 mega. And then what? And then you are given FM modulating signal frequency is given as 10 kilohertz. Or you can write this is also 0.01 megahertz. Okay. So now the issue is, if you want to determine the amplitude, that means we need to refer to the Bessel table. Okay, kita perlu refer kepada Bessel table. So therefore, from here, you see that if okay, kita kembali kepada Bessel table sekejap. So from Bessel table, if beta is equal to 0.5, okay, so 0.5 is, if you see from here, okay, so 0.5 di mana? Di sini 0.5. So I gonna get up to 2 significant sidebands. Ada 2 pasang sideband, ada carrier component. So I need to get this value 0.94, 0.24, and 0.03. Okay, so I take this parameter and I need to put here. Okay, so from the table n equal to 2 sebab ada 2 pasang sideband, 2 significant sideband. That means J0 is equal to, so J0 is equal to 0.94, J1 is equal to 0.24, J2 is equal to 0.03. Okay, so when I want to determine the amplitudes spectrum, that means I need to know the amplitude, I need to know the frequency as well. Okay, so in order to do this, we need to draw a table. Again, when you draw a table, jangan guna ruler, buang masa. Okay, so here is Jn. So I can put like this. So I want to find amplitude. So that means I must put here amplitude. Amplitude. And then I need also to know the frequency as well, which is here is LSB. Let's say I write in terms of megahertz. Okay. And then what this is, I need to find also USB, upper sideband. LSB is the lower sideband. USB is the upper sideband. Okay. So starting from J0, so J0 is equal to 0.94. So I need to find V0. V0 is equal to J0 multiplied with VC. So you will get this equal to, so this is 0.94 darabkan dengan 1000. So you get here 940. 940 volt. Okay, and there's no sideband over here because this is the center frequency. which is the carrier frequency center. Okay, and then what? I need to find V1. So here from J1 here is 0.24. So therefore V1 is equal to J1 multiplied with VC. So this is actually equal to 0.24 multiplied with 1000. So we get here 240 volt. What about the frequency? So this is the first sideband. Okay, kalau first sideband bermakna untuk mengira lower sideband, so dia adalah FC minus FM. Okay, sideband yang bawah. So di sini FC plus FM. Okay, so this is actually equal to 10 mega. Okay, 10 megahertz minus 0 FM here saya dah 10k 10k ataupun so it's easy for you to use the same unit mega. So 10 kilo equal to 0.01 mega. So minus 0.01 megahertz. So this is actually equal to 9.99 megahertz. Okay. So similar here is equal to 10 mega minus, sorry, ni plus plus 0.01 megahertz. So this is 10.01 megahertz. Okay, and then so you bayangkan ini baru 2 sideband. Kalau ada banyak sideband macam mana? Lagi penat. Okay, so J2 is equal to 0.03 and we want to calculate the amplitude. The amplitude is V3, which is equal to J3 times VC, which is equal to 0.03 multiplied with 1000, so you get here 30 volt. And then here is FC minus, so this is the second sideband, that means 2 FM. Sebab ini adalah sideband yang kedua. Ini untuk lower sideband. Untuk upper sideband, FC plus 2 FM. Why 2 FM? Because this is the second sideband. Nanti kita akan nampak lukisan dia. Nanti saya akan lukis. So here is equal to 10 mega minus 0.02. 0.01 multiplied with 2, so 0.02 lah. So this is equal to 9.98 megahertz. Here is 10 megahertz plus 0.02. So this is equal to 10.02 megahertz. And then what? After I get all this value, then I can draw the amplitude spectrum. Macam mana nak lukis amplitude spectrum? Okay, so kita kena buka lah baru. Okay, so amplitude spectrum, remember when you draw, first don't draw using ruler, buang masa. Okay, buang masa. Again, as I told you before about drawing, what we need to know is that you draw correctly and you label correctly. Dua perkara sahaja. Okay, so this question asks about amplitude spectrum. That means, okay, that means saya buat color lain. So that means I need to draw amplitude versus frequency. Okay, amplitude versus frequency. So F here, since I use mega, so I put here is megahertz. Okay, then how to draw? So if you see from the previous this one, I have carrier component and I have 2 pairs of sideband. Oleh itu, saya lukislah. So first of all, I draw the center. Mula-mula saya lukis center. Center pada carrier, which is 10 mega. And this is supposed to be V0. V0 kalau you lihat di sini adalah 940 volt. Okay, 940. Okay, and then I have the first sideband. The first sideband here, okay, first sideband kalau you lihat, the amplitude is 240 volt. Okay, so 240 volt, saya agak-agak lah, saya tak perlu tepat. 240 volt mestilah lebih kecil. So saya agak-agak dia berada di somewhere here, for example. Okay, I do the estimation only. Saya agak-agak je. Jangan guna ruler nak agak berapa tepat. Tak perlu. So this is 240 volt. Okay, where is the location? The location here is 10.01. Here is 9.99 mega. Okay, and then what? The third sideband is 30. 30 ni kecil, so saya buat kecil lah. Saya agak-agak, okay, dia tinggi dia lebih kurang macam ni lah. Okay, so dia sepasang. So this is 30, this is 30. So where is the location? The location is FC plus 2 FM. So this is 10.02. This is 9.98. Okay, FC minus 2 FM. Itu kita dah dapat sebenarnya dalam table sebelum ini. Dah ada di sini. Okay, saya just masukkan dalam lukisan sahaja. So if you draw like this, you get full mark for the drawing. Simple. Tak perlu guna calculator, tak perlu guna pembaris. Okay. So we see from here, you draw correctly. That means you have 2 sidebands and 1 carrier. You lukis gambar tu pun you dah kira correct untuk drawing. And then what? Labeling. Biasa student terlepas pandang labeling. Dia lukis-lukis, dia lupa nak label. So dia tak dapat markah label. Okay. Labeling, label the axis, amplitude versus frequency, label the frequency, label the amplitude values. So you get full marks. Okay, so tak perlu guna pembaris. And then what? So ini boleh faham. Kalau tak faham yang ini, sila tanya. Okay, sebab saya nak teruskan kepada sub-soalan yang berikutnya. The next sub-questions, okay, if you don't understand, please ask questions. Otherwise, I will move to the next. Okay, to the next sub-question is okay. Bandwidth 99%. And find bandwidth 99%, approximate bandwidth. Find bandwidth 99% and approximate bandwidth by Carson's rule. So bandwidth di sini sebenarnya dia merujuk cari bandwidth menggunakan Bessel equation. Satu lagi bandwidth by Carson. So ada 2 perkara yang diminta untuk cari. Tetapi dalam kes ini dia katakan 99%. Ini tiba-tiba dia cari masalah, dia kata carilah 99% saja. Okay. So in order to do this, first you need to find the bandwidth using 2 methods, Bessel and Carson. Okay. So what you need to do is, first of all, find bandwidth by Bessel, which is equal to 2 times n times Fm. Okay, we already know how much is n. N is 2. Okay, ini kita dah tahu daripada tadi. Kita dah tahu di sini n sama dengan 2. Fm adalah modulating frequency adalah 10 kHz. Okay, so we can straight away calculate. This is 2 times 2 times 10 kilohertz. So this is equal to 40 kilohertz. Okay, and then what? However, the question asks 99% from the bandwidth. Kenapa dia cari masalah 99%? Kerana ini sebenarnya dia nak merujuk kepada filtering system, where the filtering system only cover up to 99%, for example. It depends berapa persen you nak cover for the filtering system. Okay, so therefore 99% of bandwidth by Bessel is equal to 0.99 multiplied with 40 kilohertz. So this is equal to 39.6. 39.6. Okay. And then what? Then the question asks bandwidth by Carson. Kelas kalau tak faham boleh terus tanya. Bandwidth by Carson is equal to 2 times delta F plus Fm. Okay. So we already know delta F. Delta F kita dah dapat dalam persamaan sebelum ini. Delta F bersamaan dengan 5K. 5 kilohertz. Okay. So this is 2 times 5 kilohertz plus 10 kilohertz. So this is 15 times 2, so 30. Okay. And then what? The question asks 99%. So 99% of bandwidth is equal to 0.99 multiplied with 30 kilohertz. So this is equal to 29.7. 29.7 kilohertz. Okay. So to all of you, I would suggest you to highlight your final answer. Contoh saya buat macam ni lah. So this is my final answer. Ada pelajar suka buat hashtag. Tak ada masalah, no problem. It's up to you. But you need to highlight your final answer. Why? Because in the final exam, the student answer would be berterabur. Sometimes the answer will be above, sometimes on the side, sometimes anywhere in the center. So dia berterabur. So it takes time for me to find your answer. So kalau saya tak jumpa jawapannya, maka salah lah. Okay. So if you can straight away guide me to find your final answer, it would be better. Okay. So I would suggest either use a underline or you can use hashtag or whatever, as long as you underline your final answer. Okay. So finish these questions, and then the next question. What is the next question? Okay. Okay, kalau kita lihat kelas saya nak merujuk, okay, from here 99%, what is this actually? Okay, so let's look from this spectrum. Daripada sini mungkin you akan nampak. Okay, so let's do different color. So perhatikan kelas. So kalau you lihat di sini dia punya, kalau asal ini yang sekarang ini, this one if you see from here, the bandwidth is actually 40. Macam mana 40? 20 plus 20 to 40 kilohertz. Ini pun telah kita peroleh dalam Bessel bandwidth 40. Okay. And if we want to draw the 99%, okay, so 99% is, for example, somewhere over here. Saya buat garis putus-putus ya. Saya buat garis putus-putus seperti ini ya. And it is somewhere over here. Okay. So you see that I draw an imaginary boxes. I draw an imaginary box. Okay, kalau you lihat di sini ni box yang ini ya. Okay. So this 99% of bandwidth is equal to 39.6 kilohertz. Maknanya apa? Kalau ada filter, if we design a filter that can cover up to 99% of the bandwidth, that means sideband yang terakhir ini akan terkeluar. The last sideband, in this example, the last sideband would be removed. And we're going to take up to the first sideband only. Nampak Kalau ini adalah filter, maknanya filter tu dia ambil yang 39.6 and it remove the rest. So, maknanya dalam filter punya ini katalah ini adalah filter punya system. So we take the the carrier component and the first sidebands, and we remove the second sideband because it cover only 99%. Okay, so then kita boleh jawab soalan seterusnya. Okay, the next question actually asks like this. The next question asks like this. Kita dah jawab yang ini sudah. Number 7. Power in the smallest sideband of the 99%. So within the 99% bandwidth, what is the smallest sideband power? Yang mana satu? Okay. So now you can see from here. So from the 99%, yang ni, the one that I have highlight here, within the 99% of bandwidth, I have the carrier component and I have the first pair of sidebands. So if you see from here, the smallest dari segi amplitude yang paling kecil adalah sideband yang pertama lah. This is the smallest. Okay, the highest is the carrier component in this example. Okay, so therefore, the smallest power in the smallest sideband would be in the first sideband. Okay, bermakna P smallest kalau saya letak, saya tulis lah, saya tulis. Okay, so saya tulis jawapannya di sini. P smallest power in the smallest sideband of 99% adalah bersamaan dengan equal to P1, power of the first sideband. So saya akan ambil satu saja sideband, saya tak ambil dua-dua. Sebab dia tanya cuma satu, what is the power of the smallest sideband? Sideband yang paling kecil tu berapa power dia? Dalam kes ini adalah first sideband. So saya merujuk kepada P1, which is equal to V1 square over 2R. Okay, V1 square over 2R. So kita sudah dapat nilai V1, which is 240. So this is actually 240 square. Divide with 2 multiplied with R. How much is R? R is given as 50 ohm. R telah diberikan sebagai 50 ohm. So this is 40. 50. So ini berapa? So 240 square divide with 100. So you get 576 watt. Okay. So 576 watt. So this is the power in the smallest sideband of 99% bandwidth. Ni ada bandwidth. So class, kalau, okay, if let's say the power does, if let's say the question does not mention about 99%, katalah, okay, soalan tak sebut langsung pasal 99%, that means, okay, that means we can consider the whole bandwidth. Okay, saya bilang, kalau soalan tidak menyatakan secara spesifik power in the smaller sideband of the 99% bandwidth, then you perlu tengok keseluruhan. Dalam konteks itu, dia bermakna merujuk kepada yang inilah. Okay, tertibuk. So, kalau dia merujuk kepada keseluruhan bandwidth, yang paling kecil adalah P2. Okay, yang paling kecil adalah P2. Okay, so P2 adalah V2 square over 2R. That one is we consider the whole bandwidth. Okay, so for your information, this kind of question has been come out in the previous final exam. Pernah ditanya dalam beberapa semester yang lepas. Macam mana bentuk soalan? Okay, kalau dalam exam yang lepas, ni saya lukis sikit. Dalam exam yang lepas ada banyak sideband. Saya tak ingat berapa banyak. Okay, so let's say I draw like this. Saya lukis sinilah. So dalam exam yang lepas, I don't remember which semester, tapi ada beberapa lah. Let's say 4, katalah 4. Okay. Okay, so dalam soalan itu kalau you lihat, okay, selepas dia cerita macam ni, dia punya cerita, dia ada cerita dia, sebabnya modulator, okay, after modulator, we pass to the band pass filter. Ini dia. Okay, so keluaran modulator kita boleh dapat tadilah VFMT lah. Then we pass to the band pass filter. For example, band pass filter cover up to certain frequencies, certain megahertz, certain hertz, certain frequency. Okay, katalah you diberikan X, the bandwidth is equal to X hertz. Okay, that means the band pass filter will filter out the unwanted frequency spectrum and remain the others. Okay, kita nak ambil sebahagian sahaja. So what happened is that, so from the original bandwidth, we pass to the band pass filter. So band pass filter will select. Okay, so I don't remember. I think we select up to a few. For example lah, contohlah, katalah dia cuma select yang ini, up to the second sideband. For example, contoh. Okay, so we take up to the second sideband and we remove the third and fourth sideband. For example, contoh. Nampak So the next question would ask, ada ditanya dalam soalan itu cari power. I don't remember how much is either total power or find the smaller sideband. Katalah soalan tanya find the smaller sideband after the band pass filter, that means the smallest would be the second sideband in this example, dalam contoh ini. Yang paling kecil lah, power yang paling kecil dalam example ini P2 lah. Contoh, kerana P3 dan P4 telah dikeluarkan oleh band pass filter. Okay, so itulah you kena cari. Dia ada tanya berapakah power, saya tak ingat power apa yang ditanya. Tetapi kalau ditanya apakah itu power yang paling kecil dalam sideband yang paling kecil, maka dalam contoh yang saya buat ni adalah P2 lah, P2 yang kecil. Okay, and if let's say the question asks about the total power, the new total power after band pass filter. So the new total power after the band pass filter, you can do like this. P total is equal to P0 plus 2 times P1 plus P2. In my example. Okay, sebab filter ini dalam saya punya contoh dia up to second sideband. Okay, so total power selepas band pass filter dia telah kecil menjadi P0 plus 2 times P1 plus P2. Okay, so itulah kisahnya dalam final exam. Kita boleh uji pelajar, kita tambah satu band pass filter dan kita lihat adakah pelajar faham bahawa band pass filter we want to select only sebahagian bandwidth sahaja. Okay, and another thing is that ada lagi soalan juga berkenaan dengan find the sidebands power. Ada soalan yang macam ni P sidebands. Apa maksud P sideband? P sideband bermaksud kita nak kira sideband power. Bermakna you kena kira power of the sidebands only. Okay, kalau you lihat dalam total equations, dia ada sebenarnya macam ni PT is equal to P0 plus 2 times P1 plus P2 until Pn. So if the question asks find the sidebands power, soalan nak tanya berapakah power pada sideband sahaja without the carrier. Pernah juga ditanya seperti itu. So kalau dalam case tersebut, then you cari sideband power sajalah yang ini. Okay, sepasang atas dan bawah. That's the sideband power only without the carrier component. So tak perlu confuse lah. Sideband power adalah power untuk sideband. Total power adalah untuk semua. Simple. Okay, straightforward. Okay. Then what? Seterusnya, ini kalau ada soalan sila tanya. Okay, sila tanya. Tadi jawapannya adalah yang inilah 576. Okay. Next one. Okay kelas, kalau ada soalan tanya kalau tak ada saya teruskan. Okay. The last question asks about total power. Okay. So total power, so ini macam biasalah total power bersamaan dengan P0 plus 2 times P1 plus P2. Ini berapa? Kalau dilihat di sini adalah bersamaan dengan, so ini you boleh buat bersamaan, ini kalau kita lihat tadi. Yeah, so 940 square, 940 to 40, 30. Okay, so sorry, ini you boleh buat macam ni lah, buat apa macam ni. So ini sama dengan J0 square PC plus 2 times J1 square PC plus J2 square PC. Okay, so J0 square, J0 square tadi kita dah lihat 9424 0.03 so susah buat kat sini, saya tulis kat sana lah. Ya, sorry. So okay. Ni saya nak tunjuk dua-dua lah, senang Saya tunjuk dua-dua, maknanya so P total is equal to P0. P0 plus 2 times P1 plus P2. So this is equal to 0.94, sorry, J0 square PC plus 2 times J1 square PC plus J2 square PC. Okay, so 0.94. Okay, 0.94 square PC tadi berapa? PC telah diberikan dalam soalan, kita dah cari 10K. So 10K plus 2 times 0.24 square 10K plus 0.03 okay, so this is supposed to be a big bracket. Okay, so ini berapa? Cuba kira. So here is 0.94 square times the 10K. So this is 8836 plus 2 times ini berapa? So 0.24 square times 10K plus 0.03 square times 10K. 585. So this is 585 times 2 plus 8836. So I get 10,006 watt ataupun 10.006 kilowatt. So I can also calculate PT is equal to PC, which is equal to 10 kilowatt. Okay, so either one is okay, no problem. Okay, salah satu boleh. Okay. Okay, so go back to the questions. Total power, okay, finish lah. So selesai. Ada soalan nak tanya? Do you have question to ask? Otherwise, I will move to the next example. So macam saya cakap tadi sekejap here, mana tadi? Okay. P sideband P sideband ataupun pernah juga ditanya sideband power is the power of the sidebands. Another one is P information. Apa maksud dia? Find the information, total information power. Contoh pernah ditanya tentang total information power. Maksudnya adalah power of the sideband. Why? Because information contains in the sideband only. Carrier does not contain information. Okay, so total information power or total sideband power, that one is referring to the sideband's power. Okay. Ada soalan nak tanya? 3.9. If not, then we can see the next example. Next example ni penat sikit. Ada soalan? Kalau tak ada soalan, kita boleh pergi kepada example seterusnya. Ni soalan ni agak penat sikit. So, tapi okay, kita akan jawab. Example 310. Okay, an FM signal with 5 watt of carrier power. Okay, so this is PC. Okay, it's fluctuating at the rate of 10,000 times per second from 99.96 MHz to 100.04 MHz. Maksudnya apa? Maksudnya kita ada a carrier, okay, 5 watt. Okay, so this carrier is fluctuating to a range of frequencies. Maknanya dia fluctuates daripada ni 99.96 until 100.04 megahertz. So fluctuates here means that dia oscillate ataupun dia berayun sebanyak 10,000 kali dalam satu saat. Apa maksud dia? Ini seperti gambar raja, seperti gambar raja yang sebelumnya. I flashback. This one. Right. So kalau you lihat di sini gambar ni, carrier frequency at the center over here, carrier signal, carrier spectrum, carrier component, so oscillate 10,000 times per second. So that oscillation is depending on the VMT. Nampak dalam gambar raja ini So VMT berubah. Nampak VMT berubah. Ini baru satu cycle. So FC berubah, FC plus delta F, and then FC minus delta F. So this shows you only one cycle. Kalau 10,000 times, maknanya ada 10,000 cycle per second. 10,000 kali dalam satu saat. So the rate of oscillation is depending on FM, modulating signal frequency. Okay, so FM here determine the rate of oscillation. Kalau 10,000 times per second, bermakna FM bersamaan dengan 10 kHz. So kadar oscillation bergantung kepada nilai modulating signal frequency. Manakala nilai delta F bergantung kepada nilai VM, peak value. Nampak so ini peak value dia di sini So peak value determine the delta F parameter. Okay. So I go back to the slide. Okay. I go back to the slide. Before that, are you still there? Anybody can respond? Can you see my slide? You can hear my voice?
Yes, Doctor.
Okay, thank you for the response. Saya risau saya cakap sorang-sorang, okay? So you still there? That's good. Okay, kalau ada soalan boleh tanya. So that's the situations. So from here, we can see that from here, FC is the center, and the range is from 99.96 until 100.04. Okay, and it fluctuates 10,000 times per second, 10,000 kali. So this actually referring to the modulating signal frequency, which is 10 kHz. How much is FC? FC is located at the center. So the question asks, okay, first question. So the first question asks, how much is the FC? So FC is equal to 100.04 plus 99.96 divided with 2. So this is 100 megahertz. Ini kalau secara congak pun you boleh agak tengah-tengah tu mestilah yang center tu mestilah pada 100. Secara congak kita boleh nampak daripada lukisan ni lah. Di tengah-tengah tu adalah 100. So maknanya dia oscillate 0.04 mega ataupun 40 kHz and 40 kHz. So dia punya range 40 and 40, that means 80 lah. So itu soalan yang seterusnya. Carrier swing. So carrier swing is equal to the range of the oscillation from 100.04 minus 99.96. So here would be 80 kilohertz. Okay. Ataupun you know, okay, ini mungkin kamu tak nampak, so saya buat macam ni lah sekejap. So actually like this 0.08 megahertz ataupun bersamaan dengan 80 kilohertz. Okay. And then the question asks frequency deviation. Frequency deviation is half of the carrier swing, separuh daripada carrier swing. So you see that here from the picture here is delta F, delta F. So frequency deviation delta F is equal to carrier swing divide with 2. So this is 80K divide with 2. So this is 40 kilohertz. Nampak eh? Then what? The question asks modulation index, beta. So beta is equal to, so beta we can do like this, beta F is equal to delta F over Fm. So because we already know both of these parameters, okay, Fm already known here, the rate of oscillation, 10,000, okay. So therefore, 40 kilohertz divide with 10 kilohertz. So this is equal to 4. But so this is equal to 4. Okay. Selesai. Then what? Power spectrum. Ni yang penat sikit. Okay. So you see that power spectrum. Previously kamu dah lihat amplitude spectrum. Amplitude spectrum kita lukis V versus F, V versus F. Kalau dia buat dia tanya relative amplitude, relative amplitude spectrum bermakna J versus F. If the question asks power spectrum, bermakna dia nak melihat power versus F. Okay, maknanya you kena lukis power versus F. And how to do that? Okay, how to do that? We need to refer to the Bessel table. Okay, so Bessel table again lah kita kena pergi kepada whiteboard. Okay. So you see that we have parameter beta F is equal to 4. So according to the Bessel table, so let's look Bessel table ni ya. So kalau 4, if beta is equal to 4, that means we have up to 7 pairs of sideband, n equal to 7. Dan ini semua dia punya value. Ada 7 pasang sideband. Ini penat sikit nak kira. Okay. So tak apa, kita buat slowly So I go back here, that means n equal to 7. And we already know kita telah tahu nilai FC which is equal to 100 mega. We already know the value of FM. We already know the value of FM, which is 10 kilohertz or equal to 0.01 megahertz. Now we want to draw the frequency spectrum. Sorry, we want to draw the frequency spectrum, but this is power versus frequency. So how to do that? So kita buatlah table. Again, tak perlu guna pembaris jangan guna pembaris. Buang masa. Okay. So that means I need to make a table Jn. So table saya besar lah sebab ni, and then power. Because I want to draw power spectrum. So the power unit is watt. And then I need to find the USB and LSB. So you bayangkan ada 7 mana tu? Ada LSB. LSB dalam mega. Sebab saya punya unit mega. Megahertz. USB upper sideband also in megahertz. Perhatikan So the first one is J0. J0 is equal to how much? From the Bessel table, kamu kena lihat Bessel table. Bessel table say that the value is negative 0.4. Perhatikan 0.4. So therefore, when I want to calculate P0, this is equal to J0 square J0 square PC. So this is equal to minus 0.4 square PC. How much? PC kita telah lihat telah diberikan dalam soalan PC is given in the question, which is equal to 5 watt. Okay, times 5. So this is equal to 0.8. Okay, and this is the center, so there's no upper and lower because this is the center. So move to J1 equal to minus 0.07, minus 0.07. Okay, so P1 is equal to J1 square PC equal to here, so this is minus 0.07 square times 5, so this is equal to 0.0245. Boleh cuba guna calculator. 0245. Ini unit kalau tak nak letak pun tak apa sebab saya dah letak atas ni. Ni saya padamlah. So sebab I already make this unit watt. Okay. So what about the LSB? LSB is located at FC minus FM. So this is 100 minus 0.01. So this is equal to 99.99 megahertz. Nampak What about this one? This one is FC plus FM. So this is equal to 100 mega plus 0.01, 10 kilo. So this is 100.01 megahertz. Remember kita ada sampai 7. So therefore, apa yang saya cadangkan seperti ini kelas. Okay. So if you get this kind of question where it contains many sidebands, kalau you nak kira one by one macam ini, so it will take a lot of time. So my suggestion, you can define the complete equation like this up to the first sideband, dan kemudian untuk sideband yang seterusnya masukkan sahaja berapa nilainya, you boleh kira guna calculator. So tak perlulah tulis very detail macam yang saya buat ni So saya cadangkan seperti ini to simplify the situation So J2 is equal to 0.36. Okay. P1, P2 is equal to ni you boleh kira congat dengan cara cepat lah. Maknanya 0.36 square multiplied with 5. So we understand that. So you boleh terus masukkan nilainya bersamaan dengan 0.648, 0.648 watt. Okay. W ni tak tulis pun tak apa sebab ke atas ni dah ada W. So ini you boleh terus tulis dia punya frekuensi sebab dia tolak 10 So maknanya di sini adalah 99.98. Okay, so this is 100.02. Right, so J3 is equal to 0.43. So that means this P3 is equal to 0.9245, 0.9245. Here is 99.97, 100.03. Okay, kita tambah ni, ini tambah FM, tambah 2 FM. So kelas ini saya buat ni sebenarnya adalah FC plus 2 FM ini untuk kamu lah, untuk memudahkan kamu So ini minus FC minus 2 FM, FC minus FC plus 2 FM. Di sini adalah FC minus 3 FM. Di sini adalah FC plus 3 FM. Okay. So dan seterusnya, ni saya buat cepat lah. Ni kalau kamu dah terbiasa, kamu boleh buat cepat. Okay. So J4 is equal to 0.28 0.28. So P4 is equal to 0.392. Here is 99.96, 100.04. Okay, so ini adalah FC ini adalah 4 FM lah, 4 kali FM. Okay. So J5 is equal to J5 is equal to 0.13. Ini from the vessel table. So P5 is equal to 0.0845, 0.0845. And this is located at 99.95, 100.05. Okay. And then P6. So J6 is equal to 0.05. And P6 is equal to 0.0125, 0.0125 watt, located at 99.94 and 100.06. So ini sehingga 6 FM. So this is FC minus 6 FM. Ini adalah FC plus 6 FM. Okay. And then the last one. Yang terakhir adalah J7, which is 0.02. Okay. So this is P7 is equal to 0.002, 0.002. Okay, 0.002. Okay. And here is 99.93. FC minus 7 FM. Ini FC minus 7, 7 FM. Here is FC plus 7 FM, which is 07. Okay. So macam inilah cara buat. Kalau you dah biasa buat, so you boleh terus guna calculator, terus masukkan nombor-nombornya. But be careful, don't make careless mistakes. So from here, then we can draw the power spectrum. Okay, we can draw the power spectrum. Okay, so how to draw the power spectrum? So untuk melukis power spectrum, okay. So sekejap. So power spectrum ini kena lukis panjang sikit lah. Okay, so maknanya power spectrum kalau saya buat ni aja. So ini sampai hujung lah, maknanya panjang So power spectrum, that means power in watt versus F. F dalam kes ini megahertz Okay. So katalah center dekat mana, center somewhere here. So katalah center, kalau kamu lihat center, ini kena masukkan nilai-nilai tadi T0 pada 0.8 watt. Okay, so 0.8 ni saya agak-agak je lah, 0.8 dia besar banding dengan yang lain. So ini saya buat sini 0.8. So tinggi sangat lah, sekejap Okay, so 0.8. Okay, this is at 100. So I have up to here is for example 100.01. Okay, this is so this is 100.02. This is 100.03. Okay, so ini saya agak-agak so saya ada sini satu. So di sini ada 99. 99.97, 99.96, 99.95. Okay, so what? The first sideband is kalau you lihat 0.0, so kecil so ini kita agak-agak lah, kalau dia kecil lah, you buatlah lukisan dia kecil. Okay, small. Okay, 0.0245. Okay, and then the second sideband is 0.648. 0.648, so saya agak-agak lah tinggi dia sehingga 0.6 somewhere here lah. Sorry lukisan saya tak cantik. 0.064, sorry 0.648. 0.648. Okay, so yang sini adalah lebih kurang sini lah 0.648. And then what? The third sideband 0.9245. 9245 somewhere over here. Jangan guna pembaris 9245. So ini lebih kurang dekat sini lah. Okay, 0. And then the fourth sideband 0.392. 0.392 is somewhere over here. Okay, and then what? The fifth sideband is 0.0845. 0.0845 saya agak-agak dia dekat somewhere over here lah. Okay, 0. Let's see. So I assume that it is located at somewhere here, 0. Okay, 0.845 here, also 0.845. Okay, the sixth sideband is 0.0125. So dia kecil lagi lah daripada yang ni. So saya agak-agak dia dekat sini. 0.0245, 0.0125, okay, 0.0125. Okay, so here is, okay, the 7th sideband is 0.02. Okay, 0.002. So 0.002 maybe somewhere here, 0.002. Over here is 0.002. Nampak eh? So again, drawing is correct. Ada 7 pairs of sideband yang mana dilukis dengan cara agak we estimate high and low. Okay, so I have 7 pairs of sideband and 1 carrier component. Correct drawing. Then I label the axis, I label the frequency, and I label the power. So full marks. Okay. So nampak dia ada 7 pasang sideband. Lengkap dengan power dan juga frequencies component. Okay. Sorry lukisan tidak berapa cantik. So you kena practice lah macam mana nak melukis. So this drawing, the values is based on the table. Nilai-nilai itu berdasarkan table ini. From the table I draw like this. Okay. So do you have question about this example? Otherwise we can move to the next example. Example 3.11. Ada soalan? Kalau ada boleh tanya. Kalau tak ada kita boleh teruskan. So again, the way to draw, don't use ruler. You just need to estimate the height. Agak-agak saja berapa tinggi dan rendahnya. Okay, kalau dia tinggi, tinggilah. Okay. Pelajar sebelum ni ialah bila masa terhad apa yang berlaku adalah dia main conteng-conteng lah. So satu drawing salah, label pun tak buat. So salah lah. Okay. So class, if you ask me, if you draw gambar raja yang buruk macam saya buat ni pun boleh dapat full marks, tak ada masalah. I don't care about whether the line is not straight. It's okay, no problem. Okay, walaupun garisannya tidak straight, saya boleh bagi markah, no problem. Okay, cantik atau buruk lukisan itu tidak ada markah. Doesn't matter. Okay. So I move to the next example. If you don't have questions, kalau ada soalan terus tanya. So ini kita dah jawab power spectrum. Okay. Pelajar yang penat boleh rehat, boleh pergi minum air, pergi toilet, you can go anywhere. Saya masih segar, saya boleh teruskan sampai pukul 2. Okay. So don't worry, I move to the next example 3.11. Ini pun lebih kurang macam yang tadi, tetapi di sini dia tanya tentang amplitude spectrum. Okay. So in an FM transmitter, so the keyword here is FM. The frequency is changing between 100 megahertz to 99.98 megahertz, 4,000 times per second. The amplitude of the FM signal is 5 volt. Maknanya kalau kita lukis, saya mencadangkan kepada pelajar, kalau ada soalan seperti ini, sila lukis untuk memudahkan kamu nampak apa benda ni sebenarnya. Sebab kalau kita berdasarkan for the sake of question words only, it's difficult for us to imagine. So you need to imagine to understand and to answer the question. So that means that the question says that we have this is a FC. So this FM signal has a 5 volt, which is referring to VC sebenarnya. Okay, And this carrier oscillates from 99, di sini adalah 99, so di sini saya 99.98 until 100, so until 100 megahertz. And the rate of oscillation 4,000 times per second. So ini sebenarnya merujuk kepada modulating signal frequency. Okay. Ini kalau tengok congak pun saya dah nampak bahawa FC ni di tengah-tengah, maknanya dia terletak pada 99.99. Kalau saya buat congak daripada gambar saya dah boleh agak, dia adalah 99.99. Okay, so di tengah-tengah. So the question asks, the first question, find the carrier and modulating signal frequency. Modulating signal frequency kita dah boleh tahu daripada rate of oscillation. Kita dah tahu daripada kadar oscillation itu bersamaan dengan modulating frequency, which is 4,000 Hertz ataupun 4 kilohertz. Okay. How much is FC? So in order to calculate FC, so FC is equal to 199.98 plus 100 megahertz divide with 2. So you will get here around 99.99 megahertz. Okay, ada soalan sila tanya. So selesai soalan pertama. Okay kelas, jangan malu untuk tanya kalau tak faham tolong tanya. So if you don't have question, I move to the next question. Carrier swing. Carrier swing is the distance of oscillations, the total distance of oscillations, which is from 99 until 100. So that means here carrier swing is equal to 100 mega minus 99.98 mega. So this is about 20 kilohertz. Okay, this is around 20 kilohertz. Okay. Okay, carrier swing daripada total 100 jarak 100 mega minus 99.98 mega. So this is 20 kilohertz of carrier swing. And remember that carrier swing is equal to 2 times delta F. Okay, carrier swing adalah bersamaan dengan 2 delta F. So kalau dalam kes ini, kalau ditanya frequency deviation, delta F is frequency deviation. Delta F is equal to carrier swing divided with 2. So this is 20K divided with 2, so we get 10 kilohertz. Okay. And then what? Draw the amplitude spectrum. Maknanya dia nak suruh lukis amplitude versus frequency. Okay, amplitude versus frequency. So if I want to draw amplitude spectrum, I need to refer to the Bessel table. If I want to refer to Bessel table, first of all, I need to know how much is the beta modulation index. Okay, so kita nak tengok Bessel table, kita perlu tahu beta. No beta, we difficult for us to know which one. Okay, so we need to know beta. So beta F is equal to delta F divided with modulating signal frequency. So this is equal to 10 kilohertz divided with 4 kilohertz. So this is equal to 2.5. Okay. So 2.5, according to the Bessel table, it gonna be up to 5 significant sideband. Ada 5 pasang sideband. N equal to 5. Ini you boleh tengok Bessel table lah. Okay. So Bessel said that up to 5 significant sideband. So how to draw this? Again, we need to use a table. Kita perlu ada table. Barulah kita tahu berapakah nilai amplitude, berapakah nilai frequency. Okay. So okay, so kita telah tahu bahawa nilai FM is equal to 4K. We already know that FC is equal to 99. So at 4K here is equal to 0.04. Padam sikit ya. Okay, saya buat kemas sikit. So modulating signal frequency is 4 kilohertz, or you can say that 0.04 megahertz. Kenapa saya buat mega? Kerana FC dalam mega. Okay, so FC is equal to 99.99 megahertz. Okay, and we already know how much is VC. So VC is given in the question, which is 5 volt. Okay, VC telah diberikan dalam question. Okay, so now in order to determine the amplitude, we need to make a table. Okay, so ini adalah J. This is this is JN. This is amplitude. Amplitude with voltage. Okay, and here is LSB in megahertz. Here we want to calculate the USB upper sideband in megahertz. Nampak eh? So you need to refer to the Bessel table. So Bessel table said that J0 is equal to minus 0.05, minus 0.05. So that means V0 is equal to J0 times VC. So this is VC. So this is 0.05 multiplied with 5. So you get minus 0.25. This is the center, so there's no upper and lower because this is the center frequency, center component. And then J1, again from the Bessel table, J1 is equal to 0.5, 0.5. So this is V1. So V1 is equal to J1 times VC. So this is 0.5 multiplied with 5. So you get 2.5. You get 2.5 volt. Volt ni tak perlu tulis pun tak apa sebab di atas telah ada unit. Okay. So here is FC minus FM. So this is 99.99 minus 0.04. Okay, so this is 99.986. Okay, 99.9. Oh, sorry, ini lagi kecil sorry. So ini sebenarnya 0.004. Very small. 0.004. So ini sebenarnya 0.004. So sorry about that because this is 4K, not 40K. 0.004. So this is 99.986. mega. And here is FC plus FC plus FM, FC plus FM. So this is equal to 99.99 plus 0.004. Example ni dia menyusahkan sikit. So this is equal to 99.994. Okay, dan seterusnya. Okay, so that means seterusnya you boleh buat masukkan terus nombornya. You kena faham bahawa di sini adalah FC minus 2 FM. Untuk yang second minus 3 FM, minus 4 FM, minus 5 FM. Di sini adalah FC plus 3 FM. 4 FM, 5 FM dan seterusnya. So maknanya J2, sorry ini 2 FM sorry. So J2 is equal to 0.45. That means here V1 is equal to J2 times VC. J2 times VC you will get equal to V2. This is equal to 2.25. Okay, J2 darabkan dengan VC, you akan dapat 2.25. FC minus 2 FM. So you will get here 99.982. 99.982. FC plus 2 FM bermakna di sini adalah 99.998. Tambah 4K. Okay. J3. This is equal to 0.22. 0.22 from the table. V3 is equal to J3 multiplied with VC. So 0.22 times 5, you will get 1.1 volt. And then here is FC minus 3 FM. So 99.97, this is 978 978. Ini tolak 4 je lah. Daripada sini tolak 4 4K. Okay. So here is FC plus 3 FM. So 99. So ini dah jadi 100 lah. So 100.002 megahertz. Okay, ini 100 saya padam sikit. .002. J4 is equal to 0.07. 0.07. So V4 is equal to J4 times VC. So this is equal to 0.35 volt. Okay. Here is FC minus 4 FM. So therefore 99.974. Here is FC plus 4 FM. So becomes 100.006. Ini tambah 4 je lah. Okay. So dia berkait. The last one. J5. J5 is equal to 0.02. Therefore V5 is J5 times VC. So this is equal to 0.1. Okay, equal to 0.1 volt. Over here is 99.970. Okay, FC minus 5 FM. Over here is FC plus 5 FM, which is 100.010 megahertz. Okay, then what? Then we need to draw. Ni belum habis lagi. So mari melukis. Okay. So when you want to draw amplitude spectrum, okay. So amplitude spectrum means amplitude in volt versus F. So dalam kes ini kita menggunakan mega. So buatlah sini megahertz. Okay. Then what? So find the center. Saya suka lukis daripada center sebab kita perlu tahu di mana center. 99. So 99.99. Okay. So center di sini kalau dilihat dia ke bawah, so negatif ni tak apalah, kita boleh lukis ke bawah sikit macam ni negatif 0.25. Okay. And then what? Pada frequency, the first sideband is 99.994. Okay, so this is the first sideband is 99.994. So the amplitude is 2.5. So 2.5 saya agak-agak dekat sini somewhere. 2.5 Ini yang paling besar lah. And over here is 99.986. Okay, 2.5. Okay. And then the second sideband is located at 99.998. The amplitude is 2.25. So dia dekat sini lah. Lebih kurang di sini 2.25. And over here is 99.982. 99.982. Tolak minus 2 FM. So this is 2. Over here. So here 2.5. Okay, 2.5. And then the third sideband is located at 100.002. So here 100.002. So the amplitude is 1.1. So 1.1 is somewhere over here. So 1.1. And then over here is 99.978. Okay, 99.178. Saya agak dia kena sama 1.1. 99.978. And then the fourth sideband is located at 100.006, 100.006 with the amplitude of 0.25. So dia kecil sikit lah. 0.35 and 0.35. So it is smaller, 0.35. And the lower sideband would be at 99.974. So here is 99.974. And the amplitude is 0.35. The last sideband, the fifth sideband is at FC plus FM, which is 0.02. Sorry, 0.1. 0.1. Ini kalau kita lihat tadi 0.1. So 0.1 is located at 100.10. 100.010. Di sini adalah the lower sideband is 99.970, 99.970. So this is 0.1 volt. Selesai. So that means you need to draw the spectrum correctly and label correctly. In order to draw, you need to know the amplitude, you need to know the frequency, then you can draw. Okay. So sorry saya padam ini tak cantik, kurang cantik. So saya kemaskan sikit lah. Okay. And then what? Ini kalau ada soalan sila tanya. Then what? Then the question asks, okay, back to the question. The question asks bandwidth by using Bessel table and Carson's rule. So ini senang lah. So bandwidth Bessel is equal to 2 times N times Fm. Okay, so remember that N is equal to 5. So 2 times 5, number of significant sideband, berapa pasang sideband, multiplied with modulating signal frequency given in the question, which is 4 kilohertz. Okay, 4 kilohertz. So this is 10 times 4, so this is 40 kilohertz. Okay, bandwidth by Bessel. If you want to find bandwidth by Carson, kalau kita lihat 2 times delta F plus Fm. So delta F is already known. Kalau Carson tak perlu tengok table, tak perlu lihat table. So delta F is given here. We already calculate delta F 10K, 10 kilohertz plus modulating signal frequency 4 kilohertz. Ini dalam soalan. So 14 times 2, 28. 28 kilohertz. Selesai. Okay. Then what? So ni selesai soalan 4 ni. Ada soalan terus tanya Tak perlu malu-malu, santai saja boleh tanya soalan. Okay. Question number 5. Find the average power at the transmitter if the modulator carrier power is 5 watt. Apa maksud dia? So soalan ini tanya berapakah power, average power, remaining power at the transmitter if the modulator itself produce 5 watt. Maksudnya apa? Maksudnya kalau kita lihat gambar, mungkin saya kena buat di sini lah. Saya buat di sini. Saya akan buat di sini. So kita perlu lihat dalam perspektif transmitter. Okay. So within the transmitter, there's what we call as a modulator. Okay, modulator. Okay, so this is a transmitter lah. This is transmitter. Remember that the total power is the power that we supplied to the antenna. Okay, total power adalah power yang kita supplied kepada antenna. So the question asks how much is the average power. So sebenarnya yang dia tanya di sini adalah average remaining power selain daripada modulator. Kalau modulator ada sekian power iaitu 5 watt, berapakah yang lain ini How much is this? How much is the average power of this? Okay. So first of all, this is given as 5 watt. Okay. So actually you can calculate how much is the total power. So total semua sekali. So P total is actually equal to PC, which is VC square over 2R. VC is given in the question, which is 5 volt. So 5 volt square divide with 2 times R how much? R tidak diberikan dalam soalan. Sepatutnya soalan memberikan nilai R. Suppose the question should provide the value of resistance. So dalam kes ini kita boleh assume R sama dengan 1 Katalah plus, let's say we assume R equal to 1. So dalam kes ini sebenarnya kita perlu melihat berapakah resistance of the antenna. Okay, we need to know how much is the resistance of the antenna, but it is not given in the question. So let's assume R equal to 1. Katalah 1 ohm. So senang nak kira. Okay. Kalau dalam exam sepatutnya R diberikan. So you don't worry about that. Okay. Kalau katalah dalam exam tidak diberi, you assume lah. Tak ada masalah. Biasanya kita beri biasanya kita beri. Kalau kita bagi pelajar assume, nanti ada pelbagai jawapan. Kami yang tanda pun penat. Okay, so dalam exam kita akan beri nilai R. Okay, so don't worry about that. So here let's assume it is equal to 1. Okay, so this is equal to 12.5 watt. Total is 12.5. So if the question asks average transmitter, so P transmitter remaining. Okay, actually the question asks the remaining is equal to P total minus P modulator, which is 12.5 minus 5 watt. Okay, 12.5 total minus 5, so you get here 7.5 watt. This is the average remaining power at the transmitter. Okay, salah satu bahagian dalam transmitter adalah modulator. Modulator is part of transmitter. So the total power is the power that we supply to the antenna. And the transmitter power, which is in this example is mentioned about the remaining sebenarnya. The remaining power of the transmitter is equal to total power minus the modulator power. So you get 7.5. Ini saya betulkan sikit, mungkin kamu tak nampak yang ni. So this is transmitter. Average power transmitter, or which is in this case is the remaining power of the transmitter. Okay. Ada soalan nak tanya? Do you have question to ask? If you don't have questions, saya akan teruskan. Kita ada baki lagi sikit masa. Ada soalan boleh tanya. So the answer is 7.5. And that's the last questions for example 3.11. Okay. So what's next? Sikit lagi Pre-emphasis and de-emphasis. So emphasis here comes from the word emphasize. So kalau pre-emphasis we emphasize kita emphasize maknanya kita naikkan. Emphasize we make it bigger. So apa yang kita buat bigger? So dalam kes ini dia merujuk kepada amplitude amplitude of the signal. Okay, so pre-emphasis is the process done in the transmitter. De-emphasis is the process done at the receiver. Satu dekat transmitter, satu lagi dekat receiver. Kalau pre-emphasis adalah proses menaikkan amplitude signal. We increase the amplitude. So this is done at the transmitter side, which is before the process of modulation. Okay, and de-emphasis is done in the receiver. So since kita dah naikkan amplitude dekat transmitter, kita perlu turunkan semula pada kadar yang sama. So if I multiplied with 10, here I must reduce 10. I must divide with 10 again, so that I can make it back to the original shape. Kalau saya naikkan, maknanya saya kena turunkan semula. So supaya kita dapat signal yang sama pada output. Okay, dia mesti seimbang. Okay. So apa perlunya perkara ini? Apa perlunya pre-emphasis and de-emphasis? So this is related to the noise. Noise ni dia akan terbawa-bawa daripada chapter 2 sampai chapter 5. Okay, kita tak boleh lari daripada noise. Noise is still there. Okay. So it said that FM signal has a non-uniform distribution of noise. So the noise at higher modulating signal is higher in amplitudes than the noise at lower frequency. Apa maksud dia? Kalau you ingat bahawa kita punya spektrum tu bentuknya macam ni, dia ada banyak. So you see that here saya lukis sehingga 3 FM. So this is FC plus 3 FM. FC plus 3 FM. So dikatakan bahawa noise level, okay, semakin jauh, semakin besar nilai FM, which is here is up to 3 FM, the noise level would be higher. Maknanya semakin jauh daripada center ataupun semakin besar nilai FM, dalam kes ini adalah FC plus N FM. Lagi jauh maknanya dia punya noise tu semakin besar. Noise besar dalam kes ini adalah noise voltage, noise level lagi tinggi. So kalau nilai FM itu kecil, nilai noise adalah rendah. Okay. So perkara ini akan mengganggu SNR. Okay, so ini ada gambarnya di sini. Okay. So you see that here FC is here, center. And over here is, you can see that until FC plus N FM. Here is FC minus, so FC plus, FC minus N FM. Okay, so you see that lagi jauh lagi besar nilai modulating frequency, lagi tinggi nilai noise level. So this is actually noise level. Okay, so this is the noise. Noise level semakin meningkat apabila nilai FM semakin besar. What about the FM signal? What about the FC? What about our VFM? So this is related to VFM. So kalau you lihat, VFMT adalah uniform. Kenapa macam tu? Okay. So inilah perlu kita kembali kepada gambar rajah sebelumnya. So kenapa VFMT dikatakan konsisten? So kita perlu lihat gambar, saya flashback supaya kamu faham. Mana gambar ini. So kalau you lihat di sini, this is carrier, this is modulating signal, this is FM, this is PM. Kalau you lihat dia punya amplitude, amplitude-nya adalah sekata stable. Dia follow amplitude yang ini atas ni. The angle modulated wave follows the amplitude of the carrier. Maknanya apa? Dalam angle modulation, amplitude tidak berubah. Yang berubah cuma frekuensi dan fasa. So that's why you see the ripples, rapat dan jarak-jarak. Tetapi dalam konteks amplitude dia tidak berubah sekata. Kalau FC dia punya amplitude sekian, maknanya modulated angle modulation punya wave juga seperti carrier dari segi dari perspektif amplitude. Sekata sama, dia follow carrier. Okey. Berbeza dengan AM. So saya nak flashback jauh sikit ya. Berbeza dengan amplitude modulation, if you still remember, mana gambar dia? Ni. Saya ambil ni lah contoh Berbeza dengan AM, kalau you lihat AM, ini FC seperti ini dan perubahan itu berlaku tinggi dan rendah. Nampak Amplitude carrier itu berubah-ubah. Ini dalam AM. Tetapi dari segi frekuensi, kalau you lihat frekuensinya follow carrier. Frekuensi fasa dia follow carrier, tetapi amplitudenya berubah-ubah berkadaran dengan input. Berbeza dengan angle modulated wave, amplitudenya kekal sama, tetapi dia berubah fasa dan frekuensi. So sekarang you nampak apa perbezaan dia sebenarnya. So I go back to the slide. Okay, I go back to the slide. Sebab ini theoretical concept, you kena faham So you need to understand so that you boleh nampak dengan perspektif yang lebih luas. Okay, so you see from here, this VFMT is consistent in terms of a level, a uniform signal level, where this is equal to VC. Okay, and you see that perbezaan the ratio of signal level and noise level. Kalau pada nilai FM yang rendah, SNR lebih besar. Pada nilai modulating frequency yang tinggi, nisbah antara signal level dan noise level menjadi semakin kecil. Bermakna SNR dia rendah. So this is not good. Kita inginkan SNR sebesar yang mungkin. Remember SNR lagi besar, lagi bagus. Tetapi dia akan ada balance. Dia akan ada pro and cons. Akan ada pro and cons. Depends on the applications. Ideally kita nak SNR sebesar yang mungkin. That's a good thing. Okay. So in order to solve this problem, we need to introduce pre-emphasis and de-emphasis process. So kalau ada pre-emphasis and de-emphasis, apa yang berlaku adalah kita boleh adjust. We can distort or we can edit. We can modify the signal, okay, by increasing the amplitude of the signal, so that we can achieve better SNR. Saya katakan di sini dalam case better, okay. Maknanya SNR itu kita nak naikkan lagi lebih baguslah. Okay. So you see that here the target is to achieve a uniform SNR. Maknanya kalau kita menggunakan nilai modulating signal frequency yang lebih besar, kita perlu gandakan signal itu pada kadar yang lebih besar. Supaya kita punya target adalah mencapai uniform SNR. Dia uniform. Bermaksud nanti you akan lihat contoh yang mana pada nilai modulating frequency yang tinggi, we can achieve better SNR. So the goal here is to achieve better SNR. Okay. Saya nak tunjuk contoh secara laju sekejap. Ini contoh dia. Ini daripada buku Wayne Tomasic. Yang mana ini dalam example ini diberikan a VCO, voltage control oscillator ataupun modulator dengan deviation sensitivity K1 1 kHz per volt. So this is perubahan hertz terhadap volt and a PLL FM demodulator. So modulator berada pada transmitter. Demodulator, this is a phase lock loop FM demodulator. Nanti you akan lihat ini PLL. Phase lock loop demodulator located at the receiver has a transfer function of KD 1 volt per kilohertz and the following input. So you ada 3 input. Ini input signal this is a FM1, this is FM2, this is FM3. Dalam real world scenario, kita tak gunakan satu frekuensi, kita guna banyak frekuensi. Dan kalau you lihat di sini, ada 3 input message, 1 kHz, 2 kHz, 3 kHz. Masing-masing ada amplitude yang berbeza, 4, 2 dan 1 volt. VP here is a V peak. So the first question asks, determine the frequency deviation keluaran daripada VCO pada transmitter. Kemudian soalan kedua tanya, tentukan nilai SNR jika diberikan noise level seperti ini. Noise level 0.1 volt pada 1K, 0.25 volt at 2 kHz, 0.5 volt at 5 kHz. So soalan 1 dan 2 dia nak tunjukkan proses tanpa adanya pre-emphasis and de-emphasis. Soalan ketiga dia suruh ulang proses tetapi dengan adanya pre-emphasis, de-emphasis. So actually the example wants to show the comparison macam mana hasil tanpa pre-emphasis, de-emphasis dan juga hasil dengan adanya pre-emphasis, de-emphasis. So gambarnya seperti ini. Inilah So kita perlu lihat contoh di sebelah kiri untuk soalan 1 dan 2. Question number 1 and 2 is on the left. Question number 3 is on the right. Okay. So you are given 3 input signal, 1, 2, 3 kHz. Okay, ini masuk ke dalam VCO So ini dalam transmitter masuk ke dalam modulator. Modulator ada transfer function K1. So in order to get delta F, so delta F is equal to F of n multiplied with K1. Okay. Sebab tadi so that you kena darab, not F, sorry. Remember KF BM, so K1 is a KF actually. So Vn multiplied with K1. So Vn is the voltage of the input. So dalam kes ini ada 3, 4 volt pada 1 kHz. So we multiplied with K1, 1K, so we get 4 kHz. Okay, Hertz per volt we multiplied with voltage, we're gonna get volt. Okay, so kita akan dapat ni 2 kali 1, 1 kali 1 kHz. 1 kHz di sini adalah ini K1. So kita akan dapat 3 delta F 3 delta F, delta F1, delta F2, delta F3. So this is transmit to the receiver, received by the PLL. PLL here has a transfer function KD, volt per hertz. So kalau kita darabkan dengan hertz, kita akan dapat sebutan voltage. So keluaran PLL adalah dalam sebutan voltage. So Vout is equal to delta F multiplied with KD. Okay. So delta F, we have 3 delta F multiplied with KD. So we're gonna get output 4 volt, 2 volt, and 1 volt. So this is similar with the input. Receiver memang perlu dapatkan signal yang asal. Okay. And dikatakan di situ dalam soalan 2 bahawa noise telah diberikan seperti ini. 0.1, 0.25 and 0.5. So question number 2 asks to find SNR. Okay, SNR adalah signal level divide with noise level. So 4 volt divide with 0.1, so we get 40 at 1 kHz. 2 volt divide with 0.25, we get 8 pada 2 kHz. 1 volt divide with 0.5 volt of noise, so we get 2 SNR at 3 kHz. So perhatikan bahawa dia punya SNR menurun untuk SNR untuk frekuensi yang tinggi. Okay. So apa yang berlaku, ini SNR semakin kecil lah. So kalau you lihat gambar di sebelah kanan, dia perkenalkan pre-emphasis sebelum VCO, sebelum modulation process, dan diperkenalkan di sini de-emphasis network after demodulation process. Okay. So apa yang berlaku adalah pre-emphasis akan darabkan signal input itu. Kalau you lihat dia darabkan kepada faktor yang berbeza. Ini darabkan dengan ini darab 1, darab 2, darab 4. So kalau you lihat 4 darab 1, 4, 2 darab 2 jadi 4, 1 darab 4 jadi 4. So dia ada faktor yang berbeza. Dan kita akan gunakan faktor ini yang sama pada de-emphasis. Okay. So keluaran VCO dapat delta F. So delta F 4 kHz 4 kHz, 4 kHz, 4 kHz. Transmit to the receiver. So ini bahagian receiver. Mula-mula masuk ke dalam demodulator. Keluaran demodulator, we gonna get V out. V out di sini 4 volt selepas darabkan dengan KD. And if we calculate the SNR, SNR-nya 4 bahagi 0.1, 4 bahagi 0.25, 4 bahagi 0.5. Kita akan dapat 40, 40, 16, 8, which is much better than the previous. Okay, much better than previous. Dia bukan semua 40, dia akan lebih baik lah. Okay. And remember that we need to reduce the signal dengan faktor yang sama keluaran daripada PLL ini. Kalau kita reduce the signal level, that means we also reduce the noise level pada kadar yang sama. So tadi saya darab 1, so saya kena bahagi dengan 1. Ini saya bahagikan dengan 2. Ini saya bahagikan dengan 4. So 4 divide with 1, I get 4. 4 divide with 2, I get 2 volt. 4 divide with 4, I get 1 volt. So saya rendahkan pada kadar yang sama. Sama juga dengan noise. Noise juga direndahkan pada kadar 0.1 bahagi 1, 0.25 bahagi 2, 0.5 bahagi 4. So 0.125, 0.125. So dia punya SNR masih kekal sama, iaitu 40, 16 dan 8. So pre-emphasis, de-emphasis will improve the SNR. Okay. So ini nanti saya akan jelaskan semula pada minggu hadapan. So now you get the picture that pre-emphasis, de-emphasis is to improve the SNR. SNR menjadi lebih baik. So that's all for today. Okay, that's all for today. So okay, so let's take the attendance and then you can move to the next class ataupun boleh berehat. So you can open your QR code reader. Okay, open your QR code reader. After you scan, then you can move to the next class. So okay. Regarding the second task of project, I will give the second task maybe this week or next week. Okay, so siapa yang dah siap first task, you can straight away submit in the author. Okay, so tak perlu tunggu sehingga 4 hari bulan. Kalau you dah siap, you terus hantar, no problem. And for the test question, saya belum sempat tanda lagi. So I will try by this week. Hopefully I can finish as quickly as possible. So see you again next week.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Kau cakap je.
Apa dia?
Doktor, saya tak dapat nak scan lah, Doktor.
Nama siapa?
Ashri Mukmin.
Ashrik Mukmin. Okay, saya dah tanda.
Okay. Thank you, Doktor.
Okay, welcome. Siapa lagi?
Doktor, saya Nur
Saya, Doktor.
Fatihah.
Nama siapa?
Nur Fatihah.
Nur Fatihah. Nur Fatihah, okay.
Nur Sharina Farisha.
Terima kasih, Doktor.
Okay, siapa lagi tadi?
Nur Sharina Farisha.
Okay,
Terima kasih doktor.
okay sama
Saya Nur Amira, doktor.
Amira. Amira binti Rahman, okay.
Doktor, saya Siti Fatimah.
Siti Fatimah, okay. Siti Fatimah bukan dah ke belum Siti Fatimah dah.
Okey, thank you, doktor.
Doktor Nurdini.
Okay, Nurdini.
Terima kasih doktor.
Okay,
Sorry.
satu lagi belum? Anyone? 3, 2, 1. Okay. So that's all for today. So